Hello everyone, now we will see backtracking in algorithm analysis. What is backtracking? Backtracking is an algorithm technique used to solve problems incrementally by trying out different possibilities and undoing decisions when a solution path is determined to be invalid. It's often referred to as a form of depth search, where we explore each possibilities but retrace our steps when we find that continuing along the current path will not lead to a solution. And now we will see characteristics of backtracking. The key characteristics of backtracking are recursive, incremental construction, pruning, exhaustive search. Now we'll see in detail about everything. Recursive. Backtracking algorithms are often implemented recursively, as they need to explore and backtrack through various decisions made along the way. And incremental constructions are it builds potential solutions step by step. If the current solution doesn't seem promising, it backs out to the previous step to try a different approach. And pruning is it effectively prunes the search space by eliminating paths that lead to invalid or infeasible solutions early on. An exhaustive search or it performs an exhaustive search of the solution space, trying every option until a valid solution is found or all possibilities have been exhausted. And now we will see how backtracking works. Backtracking starts with an empty subset, and it will try to include each number and tries out recursion, and it backtracks and terminates. So try including each number is for each number we decide whether to include it in the current subset. If including the number doesn't exceed the target sum, we proceed to the next number and try again. If the sum exceeds the targets or we reach a dead end, we backtrack by removing the last number added and try the next possibilities. If a subset is found that matches the target sum, we return true. If all possibilities are exhausted, we return false. And now we will see an example for backtracking. The n-queen problems is a classic example used to explain backtracking. The goal is to place n-queens on an end-to-end chessboard so that no two queens threaten each other. In other words, no two queens can share the same row, column or diagonal. Now we will see the step-by-step process for n-queen. Now we will start with an empty board, and we should place a queen in the first row, and we should move to the next row. Attempt to place a queen in a column where it is not threatened by another queen. And we should repeat the process for all rows. If a conflict occurs, backtrack to the previous row and try the next column. Stop when a solution is found. If no valid solution exists for a particular setup, the algorithm will backtrack and try different placements of queens. And now we will see when to use backtracking. Backtracking is most effective in problems like solution space is large or combinatorially complex. There are constraints, exhaustive search is needed. In conclusion, backtracking is a powerful, though computationally expensive technique used for solving problems that require exploring multiple possibilities, especially when constraints limit which paths are valid. Its recursive nature allows us to explore solutions incrementally and backtrack when a potential solution is found to be invalid. While it guarantees that all possible solutions are explored, it can be inefficient for problems with large solution spaces unless pruning strategies are used to limit unnecessary exploration.